This is problem number 10 from SAT practice packet number 3. If a, b, and c are distinct positive integers and 10% of ABC is 5, then a plus b could equal one of these options. The first thing we want to understand is that a, b, and c are distinct positive integers. That means that they are different, they are positive, and they are whole numbers. So you want to make sure that you understand those three words. Next thing we want to read is 10% of a times b times c is 5. So what does that mean? That means that 10% of a times b times c is going to equal 5. So we want to figure out 10% of what can give us 5. Another way of thinking about this is 1/10 of what number can give us 5. Well, with some calculation, we can see that 10% or 1/10 of 50 can give us 5. So therefore, a times b times c is going to equal 50. If we go back to the questions, it's asking us, what could a plus b equal? So we want to figure out what a, the number of a, and what the number b is. So we want to figure out what number times what number times what number is equal to 50. Well, we have a couple of options. I like working with these trees because they help me keep organized. So what if a was 1? If a was 1, then I could say 1 times 1 times 50, or 1 times 2 times 25, or 1 times 5 times 10. Those are all the combinations if a is 1. What if a is 2? If a is 2, then I can have 2 times 1 times 10, 2 times 5 times 5. If a was 3, we can't because 3 doesn't divide 50 evenly. So a can't be 3 because we want all of them to be integers, no fractions or decimals. So the next integer that a could be is 5. We can have 5 times 1 times 10, or 5 times 2 times 5. We could also have a be 10, so 10 times 1 times 5. Or we could have it be 25, 25 times 1 times 2. Or we could have it be 50, 50 times 1 times 1. So now you see that these right here could be our a values. In the middle row we could have b values, and then the last row we can have c values. Now let's organize this. If we have a, b, and c, let's figure out which of our combinations that we figured out can actually work. Well, 1 times 1 times 50 can't work because we have to have different integers, and 1 and 1 are not different, they're the same. We could have 1, 2, and 25, 1, 2, and 25, and we can have 1, 5, and 10, 1, 5, and 10. From here we can have 2, 1, and 10, but we can't have 2 times 5 times 5 because we need different integers. We can have 5, 1, and 10, but we can't have 5, 2, and 5. We can have 10, 1, and 5, and we can have 25, 1, and 2, but we can't have 50, 1, and 1 because we want different integers. So now we have all the combinations of a and b. The question is asking us, what could a plus b equal? So let's just add a and b. 2 plus 1 will give us 3. 5 plus 1 will give us 6. 1 plus 2 will give us 3. 1 plus 5 can give us 6. 10 plus 1 can give us 11. And 25 plus 1 can give us 26. So those are the possible values of a plus b that we found. Now if we go back and look at our solution, the only one that appears So the only one that appears is 3. 1 doesn't appear, 5 doesn't appear, 8 doesn't appear, and 25 doesn't appear. So our answer is going to be B, 3.